Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about AI and digital twin. So let's dive deep into it. So what exactly is the problem that we need a synergy of these two puppies? Well, first thing is things that we are building, be it a building, be it a construction equipment or whatever have you, they are becoming ludicrously complex and very hard to make right. What does that mean? That simply means back in the old days, we used to make fighter jet every 4 or 5 years, new generation. And now it takes like, yeah, we built the whole damn thing like, 20 years ago. Then why we are waiting for? Yeah, integration hell. So fundamentally, and it's not only the software part, hardware also is becoming so complicated. Meaning, if you look into your car from back in the like 1980s versus what it is right now, and you had fuel injection back then, you also had variable valve timing back then also, but we have so much extra. The integration is making, well, non-complete basically. So what does this mean? This simply means as of now, as in like 2025, software and hardware both are becoming less finished and less polished, meaning you're buying a brand new product, be it a car, be it a jumbo jet or whatever have you, they're not as good as it should be. Like half of the time, like you will be the beta tester where it's like, oh dude, this does not work, oh this does not work. I'm not even joking. Like when you actually get into the hardware engineering part, the silicon, you're like, you always read the data sheet. Yeah, many times that does not work. Not even joking. Like when you first batch of the silicons are sold to the public, they literally ask them, it's like, tell me, is any pin not working? It's like, oh yeah, we messed up the actual silicon hardware. Yeah, that does not work. So you'll be shocked like how unfinished and unpolished modern technology is. And again, it's not because nobody's trying. It's just too goddamn hard, too integrated, too complex. So that's on the reality side of it. Now, AI itself has been going through a hype chain from, let's say, 2015 to 2025. Now, in this 10-year period, you had almost a sinusoidal wave, and it's becoming a money pit right now, meaning people poured money into it like there is no tomorrow, but there's a problem. How the hell you recover the money back? No, like surprisingly large amount of AI enterprise had no possible way of justifying the equipment that they are buying. Basically, oh sir, we are buying this AI so we can do this benchmark. Awesome. It's like, yeah, cool, awesome, GG, ultra GG. What is the return ROI on it? So that initial hype, nobody cares about it because again, the market is hot. So people dump money without thinking. But as it starts to cool down, they're like, okay, sir, we gave you like, $500 million few months ago. What happened to it? It's like, no, you lost it and you need more. It's like, that happens. So as of now, AI is a very big money pit, almost like a bubble is burst. And we have sea of broken promise. Like one of the promise that was like, I genuinely wanted to be true was this Rabbit AI system where you have an AI agent that reads the screen rather than requiring an API key or like basically backdoor access from like, protocol to protocol, just like, hey, I read the goddamn UI. So this was not never real. Like this was just not real. However, I am thankful and I'm happy that some companies did figure it out. So there are web browser where you can do this. There are AI agents that can take care of your computer and do things on it, although it's a security risk, but it can be done. So what they were planning to do, other companies did finally reach it. So right now, sea of broken promises. We're gonna do this. Yeah, they did not. So too many broken promises. And compute hardware. Like these hardware, they are good high-end hardware, but there is no use of it. It's like, yeah, we can run it. It's just like, oh, what are gonna you do into it? Like these are far more expensive than a render farm, so you can't utilize them effectively, cost effectively as a like video rendering place. So, and again, nowadays render farms are not as necessary. Like there are certain workstation computer that can like literally render transformer level graphics on the like desktop environment. So like again, we have 2 terabytes of RAM available on certain version of Threadripper, Apex and all that, and again 48 gigabytes of VRAM and modern compute. It's not as necessary to have render farm as it used to be. So what the hell are you gonna do? We pour so much money. What the hell are we gonna do? So this is the fundamental problem. Our world is too unfinished, too incomplete, and AI is becoming a money pit. So digital twin is the reality. Now be mindful, digital twin was always independent, always existed. It's just that somebody figured out we have to take digital twin and have AI twin. They have to make love to each other. So digital twin is basically perfect replication to your best of technology, best of your ability, perfect replication in a computer simulation. Meaning this house that I have, I'll take every measurement or like before making it, I'll like, okay, this is what I want. So this is the floor plan, this is the idea. We'll make everything into a computer simulator, and I mean everything, meaning not only, okay, this is the brick and mortar arts, but no, where the electrical conduit, where is the air tunnels, like where is the ventilator, all of those things, like as much as we're gonna physically do into a computer simulation, not just a graphics render where you can show, architects use to, show to customer, not that. Full detail, like how many rebar you have inside a pillar, all of that, you do that. Now, what about the simulator aspect? Now, simulations, we are actually good at it. Like the game engine is also a simulator right now. And be mindful, the early simulators, they were only as good as our today's simulator that we use in video games. And again, we tone it down so it does not become too hard to play. So we can make very good simulators right now. And the simulators that are used for like high-end engineering production, those are good, like really good. And we work our ass off to make it as constrained by laws of reality as possible. What does that mean? That simply means physics, chemistry, all of that. So in a simulator, you do not say, this is the cell, this is the watt-hour capacity of it. No. You say, okay, what is the length of the jerry load? How, what is the thickness of the dielectric? What is the, like, thickness of the anode? Thickness of cathode? What is the resistance of, like, from a linear device if it's a tabless system? How you are welding the tabs? Is it cramping it? How are you cramping it? Are you laser welding it? All of those data has to be there. So it's not just, oh, this is a battery. Like in a video game, it's like if the battery is a thing, it will like, okay, this is a battery, it will run for this minute. That's not how it's done in simulation. Simulation, you try your best to make it as constrained by physics and chemistry as possible. So it's not just like, okay, we have this structure. It's like, okay, this is a pillar. Okay, now again, customer will apply pillar, then the computer will ask us, like, what is the size of aggregate that you are using on it? How much water you are pouring into it? How much rebars, like how rebars you are using, and how you're doing it? Are you welding the rebars so it's integrated, or it's like, normal hand down? All of that has to go into the simulation engine. So we do our best for physics and chemistry's point of view, so it can simulate, oh, rusting will occur. And yes, computers are that good nowadays. Simulation, to be precise. And then you simulate. Now here's the deal, that itself is just one part. Then you iterate rapidly, meaning let's say you want to make a warehouse completely humanless. You want to make it basically what Amazon has been working on. So you can directly start working, or you can be smart about it. It's like, okay, what options do we have? Okay, we have this much floor plan, cool, awesome. Build the core structure. Okay, this is the frame structure and all that. Okay, where the customers are coming in, where customers are going, as in trucks coming in and trucks going out. Okay, how the heck you gonna make sure that trucks are emptied? What robotics you are gonna use? You do not want humanoid robots. While it can be awesome, it is flexible, it does come with a penalty of low throughput. You want high throughput. So, okay, how the heck you gonna build the conveyor belt? How you gonna pull it out? Then you simulate everything, and then it's like, hey, if we use this structure, we do not have enough space for forklift to go there. Then you like figure it out, to tune it, and then you reiterate again and again until you reach a satisfaction. And again, everything, meaning whenever you are building a assembly line, you will simulate everything, every robot and its motion range, all of it, or as close as you can get. So that's the whole idea of digital twin. Now this has been there, always been there, but it was too cumbersome and complex. And again, for certain things it was valuable enough where the people just bite the bullet and paid the price and the cost of it, but not everybody did that. Now, to give you, I think I keep forgetting which company it was, either it was Boeing or Airbus. They were like, okay, we're gonna make a new factory, and they spent 2 years in CAD just to make the digital twin, because again, it was so big, so convoluted. It was like, yeah, let's make sure. And you're like, wouldn't they just wasted 2 years? No, they were very clear. Like after they have done it, the thing would have taken 8 to 9 years to build. They've only got it done in 4 years. If they did not had the digital twin, it would have been wasteful, exponentially wasteful. So digital twin has been slowly growing in the background without any issue. And again, it is productive nowadays. Now, what happens if you like take the simulator and just jam AI into it? Now, simulator takes a lot of time to set up, not to actually simulate. Simulation is good, we got this. To set up the goddamn simulation will take months or sometimes years. I'm not even joking. Like if you want to, I'm going to simulate this bridge. Simulation engine will barely take like 48 hours or maybe 2-3 weeks. Done, go home, sweet dreams. It's like, okay, how about setup? Yeah, that will take whole engineering firm working their ass off for hours, every day, for months. Actually, generally longer. That's like, okay, this bolt we are using. What is the... So it takes too much time to set up. Now, AI is very good if you have a constrained environment, meaning AI right now, when we want to make it like a Jarvis, where it's like, AI does everything. Basically, it's a human brain. It's horrendous. It's like, I have no idea what the hell is going on. However, if you give it a constrained environment to work inside this, AI is like, I got you, fam. So in constraint environment, AI is awesome. You do not want it to be like, figure out everything. No. This is a constraint environment, just deal inside. This is awesome. So simulator is that constraint environment. On top of that, simulator needs a level of intelligence, because again, you can keep going down, into the details. It's like, oh, the aggregate that I'm using is this chemistry, and it has this sort of bonding. No. You do not need to go that deep. You're like, dude, good enough. We have been simulating this. We have real world feedback data to it. It's good enough. Do not waste time into it. And again, computer can keep simulating down to that level. You have to stop it. It's like, bro, good. So it takes a certain level of intelligence to utilize simulator efficiently. Otherwise, you will waste too much time and resources. So AI is great in constrained environment. Simulation needs the intelligence. You see the point? Love making session. So that's the whole point. And filtering has to be done. Whereas like they do not get, okay, I'm simulating this exhaust fan. It's like, bro, that's not important. Is it structurally positive or negative? Only simulate that. Do not go as like, what is the impact and all that. It's like, it does not matter. So it does need certain level of filtering, whereas like noise, there will be too much data, noise in the data. You have to filter it out. And if you do not, it becomes too inefficient. So AI has the benefit of rapid iteration, very great outcome in a constrained environment, and it has feedback, meaning AI becomes self-reinforcing and better. So you can give it, this is a bridge, simulate. Now, right now, if you do that with simulation, your server will crash. But if you have this AI is like, what kind of thing we are looking at? You give it some images, like this sort of thing. Then it will keep putting feedback data loop into it, where it's like, okay, this sort of bridge, what data are available in the public domain? Collect the data, simulate that. Then see how close to real world data it is. Then keep looping it again until you reach a useful data point. And simulator is helping AI to not hallucinate. Whereas like, okay, what if I do this? Simulator is like, nah. So this feedback, iteration, feedback loop, and the fact that simulator will not allow you to hallucinate, where it's like, oh, what if I just go through this? It's like, no, you have to put a hole there. So that's the whole point, because we can simulate every pathway, but if you have AI is like, okay, do not try to simulate pathway, what happens everywhere. It's like, it's too inefficient. Just simulate intelligently, and then it's like, bam, and then you iterate, bam. So you iterate, you have feedback loop, and you are hallucination proof. So this allows that simulator to become far more useful and far more productive while removing the penalty of AI. Basically, it's making both parties work better. So what's the outcome of going through this hassle? Well, the gap between idea and execution is brutal. Meaning, if you go inside a normal teenager's boy's brain, he has like a freaking transformer running in his brain. It's like, okay, I'm going to do this and all that. But execution, yeah, lol. And like half of engineering is just executing the goddamn thing. Ideas, we good, bro. We good. We got this. Execution, yeah, no, what do you mean I have to actually make the damn thing? So that's the one of the most time consuming part. Or if you look into people who are doing YouTube projects, they will say integration hell. That's the whole point of it. For example, you have a wood router, right? And you're like, okay, I'm gonna have a simple wood channel where I'm gonna put a giant wood planks, and this router is gonna go back and forth, and it's gonna flatten the board. I'm gonna be happy about it. Cool, awesome, nothing quantum physics, no quantum tunneling needed. And you're like, okay, I'm gonna have a limit switch. When it clicks it, putung, it goes back, putung, goes back. Everything simple has been done, and you do it and it does not work. It's like, what the hell? And you keep working on it. If you had a simulator would have thrown up an error. The first thing is like, bro, router is an electromagnet, a noisy one at that. You have conductors running around it, aka the wires that are for the limit switch. Yeah, it's gonna act like an antenna, and it's not gonna be reliable. And that's why if you look into contact switch, generally they have 3 pins: normally open, normally close, and the power. That's the whole point of it. You're supposed to use both of them, or use a shielded wire. So these sort of subtle things, simulator will be like, brah. And you would be shocked. You're like, okay, who will make such a silly mistakes? Like, this is my silly mistake. I wanted to make a fume extractor. I got the hardware part done. Everything is done. Cool, awesome, GG. It's just that I've got kind of scope creeped into the fan controller part. It's like, okay, I'm going to make this. I'm going to turn it on one by one. Cool, awesome. I'm going to have like PWM control. Everything is awesome. I figured out like I have 12 volt in. I have to have 3.3 volt out for the ESP32. I will dock it here. Cool. I just forgot that how the heck I'm connecting the 3.3 volt output from here to the goddamn ESP32. I am genuinely shocked how the heck I did not think of that. Like, I thought of like, hey, let's put here the actual step down converter. I thought of that. I just forgot to think about, hey, it has to connect. Like, I could have just had one or more pin, it would have been awesome. But you see, this sort of thing happens and you would be shocked. It's like, oh, I'm an amateur. Trust me, very expert person has, but this sort of silly mistakes, that's all engineering is. removing those silly mistakes. So integration hell is not like super complex, this and that. It's like, it's basic things. And simulator is great at removing those basic things. And then it will trip up where it's like, dude, I do not know what you're trying to do. Basically, if I'm working with CV motion engine, the simulator is like, GG, I got the how cylinder reacts, piston ring reacts, the timing. The moment it comes to CV motion, it cannot do reliably. Why? Well, it's a new thing. So it has to have very high resolution, high compute in the engine's core rather than the outside of the engine core. Outside engine is like, bruh, we've been simulating the same thing again and again for millions of years, virtual time, not an issue. So fundamentally, if in this sort of scenario, AI can be only 60 to 70% efficient. Basically, it removes like 10,000 problem. It removes a lot of the super simple, oops, I missed about it, I forgot about it, all of those issues. It would save enough time to justify cost. Oh, and another benefit, hardware is same. It's not like a render farm where it's like, that's the best you can do. No. Simulator does require a certain level of compute oomph, and GPU needs is a bit different compared to a compute card. Compute card is a bit different for AI. Somehow they are exactly the same for both things, meaning AI and simulators, they can use same hardware with quite a high efficiency. So the hardware is justified. And accounting things that human mind overlooks. Let that be very clear. It's not like, oh, we are dumb or this. No, we good. It's just that we overlook. We get tired. Like, how many of you will think about it? It's like, oh, that's why all switches always come with 3 pin. Normally open, normally close. You're supposed to use all of them or use shielded wire. Like, these are subtle things. All of you know this. It's just that, oh, I forgot about this. Trust me, like, you look into anybody who's like building a 3D printer, it's never like complex things that's like, oh, how are you going to do that? It's like, bro, we got this. We good. Complex thing, we are good. It's just that, oh, I forgot to do this. Oh, yeah. So if we can solve that sort of thing, the outcome would be magnificent. Basically, you built a whole car engine production plant, you simulate the hell out of it, and it's like, oh, okay, robots are too close to each other. Whenever it's moving the plank or going there, it will hit it. So you have two options, either time it such a way that it does not hit, or increase the space. Then you can simulate that. It's like, hey, so run one simulation where you increase the space, what is the penalty? Run one simulation where you time it that it does not interfere. And again, you will get the outcome. Then you will feedback again. So outcome is magnificent, basically reducing the gap between idea and execution. And it only has to cost 60 to 70% threshold where it's actually cost effective. Because again, whenever you're talking like, oh, AI is expensive, look into the factory costs. And at that point, AI is like, not that bad. And if you're like, hey, we a firm, let's say we are a company who does a digital twin AI simulation for you, and like, how much money you gonna save? 10%? Shut up, take money. Shut up, take money. So outcome is magnificent. And again, that's why Tesla is so hell-bent on like simulating everything, collecting all the data from Tesla cars and then running the simulation in the system. Although they are a bit stupid because they forgot the whole law of computer. Garbage in equals garbage out. Cameras are garbage. You're supposed to use LiDAR. So, and again, that's why Chinese companies already, bro, we already have self-driving. Other car companies, we have self-driving. Legal in USA. LiDAR. Garbage in equals garbage out. So outcome is magnificent here. So what can we expect from the future? Well, this is the gold mine of profit. Basically, everybody figured out how to make AI. We good, we got this. We are sorted on that part. But how the heck you make profit? This is where you make profit, because you have to understand, what does money do not buy? Time. Like if you have Boeing, you have Airbus, both of these puppies have, let's say, $1 billion. What they cannot buy a single second of? Time. They cannot be like, okay, this project has to be done in 10 years. They cannot be like, okay, I'm going to burn some amount of money, I'm going to get 11 years. That's not going to happen. So they have to get things done in 10-year period. So at that point, what's the next best thing? Speed. Improve the speed, reduce inefficiencies. So at that point in time, that service, like let's say you are a firm that is offering that service from giant computation hardware where you're running AI and simulation, you can offer big enough savings in time where companies will be like, oh, how much is your charge? 100 million? Take it and go. Don't ask me, just save me time. More than enough project success where you can sell the service, have profit even for hyper expensive AI clusters. So fundamentally, and what would be the expectation outcome of it? Tech can finally improve our project yield. Meaning, when I was building this, it does work pseudo level. Is that I wanted a system where you do not need an app. I was tired of the idea of like every Wi-Fi control device requires an app. I'm like, why? You're supposed to use a web page, so it does not get a oh, app you have to update. No, you're supposed to have a access point kind of nature. You click it. It's like, okay, type the password which you can have printed it here, and then feed in the password. Website, control it. And again, it can be done with ESP32. I did manage to do it. It's just it was sloppy. Certain things were not working. Again, if it was simulated well enough, then computer could have run the simulation inside itself. It's like, okay, ESP32, I was using, the fans have tachometer output, computer fans, 4-pin PWM. So PWM speed control was good enough, but tachometer fan, I could not read the RPM reliably. It's like sometimes it was reading 15,000 RPM. Like, what the hell? If I wanted to use... instead of interrupts, I wanted to use what we call pulse counter. It's far more stable. That's how your motherboard does it. But it did not work. Pulse counter or something like that. Counter like it is there, it does work, but it was not reliable enough. If I were able to simulate it in a computer, AI can do it itself. Like this individual wants this, let me simulate few iterations of it. What is the closest that works? And then it would have given me that. Then I would have worked it and given the output of that real world to that's AI. AI is like, okay, I got this. This is what's working. This is what not working. Let me fine tune it. 2-3 iteration, boom, software code, install it, done, go home. So that's the whole point. This is what we want out of our products. Like, you know, when we say it just works, that should be doable now. In principle, not just yet, but in principle, like I want a humanoid robot. You should be able to build it. Just like boom, done, go home. Of course, money, like there is no tomorrow, but you should be able to do it. Right now, you can't. Like if you are old enough, you must have remember Honda made a big deal with their Osmo robot in year 2000 and it was really good. But then why did not do it? It was expensive, but it did not have the brains part of it. And robotics was very limited, not because of the hardware, because the software was not refined enough. Nowadays, that's not an issue. Why? We keep simulating in the AI part of it. That's why you will keep seeing NVIDIA talking about how they are simulating humanoid robots. Basically, they design the thing, feed the data into the simulator, simulate 10,000 code iterations, and then they're like, okay, this one has the most chance of actually working, and then run that into limited environment in real world, give the feedback again to simulator, and boom, 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 boom. So things that would have taken years is like few months, take it and go. So this is fundamentally awesome, where you can have project that has higher yield, time estimation is almost realistic, and validity is really good. Whereas like, no, we are making a humanoid, it works. You are making a self-driving car, it works. So that's the whole point. Now, would it have impact on job market? Early days, no. Might even create a job increase in early phases. However, over time, what I'm talking right now, it will be only be used for large scale. But imagine the same thing. Imagine this sort of thing can be done reliably enough. And again, companies will offer you, it's like, hey, our service is a bit more expensive, but it's higher reliability. It's like 98%. Some company will like, bro, ours is 95. Some other company will like 99.98%. Again, that's a bit high. But again, they could have domain. It's like, bro, we are the company that fine-tune for solar panels. It's like, we got the fam. Like, you want solar farm, you come to us. Other company like, bro, jet engine, we got this one. Rocket company, we got this one. So there's a lot of scope. And this point, you can actually make your money back. So it's like, we burnt $1 billion to make this data center. It's like, bro, we got this. We good. If the money will come back in like 3 to 8 years, we good. ROI is possible in principle. So future is there. And I'm pretty sure a lot of people, when the tariffs is causing a lot of dip, they're like, oh, I missed the pandemic dip. I'm not missing this dip. I'm not missing the Trump dip. They're buying the stocks, S&P 500. They're just buying it. And then like 4 years from now, they're like, money. And this is why NVIDIA is focusing on right now, digital twin. There's actual probability of profit yields, magnificent yields. So this was my presentation on this whole idea of taking AI and simulator and making left together. So hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.